Hey there boys and girls, let's have a look at maths for today. So it's Wednesday and we are looking at what is a fraction. So for this lesson, if you're working on paper, you will need a pencil or something to write with, your exercise book or paper, and a rubber and a ruler if you have them at hand. Of course, alternatively, you can complete it on the worksheet electronically and send it via Dejo as well. So the goal is we're learning to understand fractions. So yesterday we looked at unit and non-unit fractions, and today we're going to just pick apart fractions and go into fractions and what fractions are in a little bit more detail. Before we do that though, I'd like to have a go at the starter. Okay, so we're going to, once again, a bit like Monday, we're going to recap perimeter and area. So I would like to calculate the perimeter and area of these three shapes. Okay, just a quick recap. Remember, let's get my pen option on. Remember, perimeter equals length is when you add all the sides up. So it's the outside. Perimeter equals the outside of a shape. The area equals the inside of a shape. So if you're working out the perimeter, you just add the sides up. So if we look at A together, we'll talk it through, but you can work out the answer. So if this side here is 7 centimeters, then we know that this side here is also going to be 7 centimeters because they are parallel sides. Likewise, if the length of the shape is 12 centimeters, we therefore know that this side here is also going to be 12 centimeters because once again these two sides are parallel. So once we have those measurements, we can then add them all up to find the perimeter. 12 add 12 or double 12, double 7, and then you get your answer. Okay. And to work out the area, remember you just simply do length times the width. So you're doing 7 multiplied by 12, and that will give you your area of your rectangle. Okay, so that's how you work out A. Remember, B is a square, so the sides are equal. So you're simply squaring this number, or you're multiplying this number by the same number. Okay, because each side would be 8 centimeters. All right, so you're doing 8 times 8. That will give you your area. And again, perimeter, all the sides of a square are equal, they're the same length, so you can add them all up, alright, or multiply it by 4. Shape C is what we call a compound shape. So what we do here is we have to split the shape into 2, which I've kind of done for you just here. Alright, so the first thing we then have to do is work out the missing sides. So if we know that, again, we just need to work out the missing sides. I'm just looking at this myself. So we need to calculate the top length here. If we know that the full length is 110 meters and we know that the length here is 50 meters, if we we're trying to work out this length here, and to work out this length we'll have to subtract that from the total length. Okay, so that will give us the missing side here. You also know, once you've got that, you'll know what this side is here, which will then help you work out that. Okay, and then finally you need to also work out this side here. If we know that from here to here the length is 70 meters, and from here to here the length is 40 meters, we're calculating this. Alright, so we're calculating 70 take away 40, which will give you a missing side there. We'll go through that in a minute as well, okay, but I'm going to stop talking. I want you to pause the video and have a go. So pause the video now, good luck. Okay, welcome back everyone. Let's see how we got on. So working out the perimeter first, we need to add all the sides up. So we know that's 7, we know that's 7. They're parallel, so that would also be 12. And then we simply add them up. Okay, so double 7 will give me 14. Double 12 will give me 24. And then if I add them both together, excuse my writing, still quite have a massive writing on the mouse. We add up our 1s, we add up our 10s, it gives us the answer of 38 meters. Alright, so perimeter equals 38, P equals 38 meters, and the area, I would multiply this together, so 7 times 12 would give me 84, so the answer would be 84 centimeters as well. Okay, notice that they're in centimeters, not meters. A proper C in there as well. All right, and moving on to B. If you add up all the sides, or 8 times 3, you get 32. So you get P equals 32 centimeters, and then your area would be 8 times 8, which is 64. So it's 64 centimeters with a squared to 2 at the end. Okay, and then looking at the compound shape at the bottom here, working out the missing side. So I said earlier that this is 110. That's 50. So if I subtract that 110, subtract 50, that gives me 60. So I know this side here is 60 meters, 60 m. Then I also know, looking at this, so I know that this now is also, I know that this now is also 60 meters. My mouse is all over the place today. 60 meters, and this is 50 meters because these two sides are parallel. Also, if I do 110 subtract 60, that also gives me 50. Okay, and then once I've worked that out, I can add them all up, and that will give me my total. All right, so I'd add them all up. So 60, or I've got that already. So 110 add 40 is 150. Add another 50 equals 200. This side I forgot to calculate. This side, if I do 70 take away 40, that gives me 30. Apologies, I missed that one out. Alright, so we've got 110 add 40, 150, 200, 230, 290, 360. So your perimeter would equal 360. So P equals 360 meters squared. Alright, and then your area we'd have to work out the area for this first. So I would say that this, I'd label this as A, and this is B. Alright, so then if I was working out the area, I might not know what 50 times 40 is, but I know that 4 times 5 is 20. And then I simply add on my zeros. So I've got 2 zeros, which will give me 2,000. Alright, so I know that will give me 2,000 for A, 2,000 meters, the area, and then for B I do the same, but I do 60 length times width, 60 times 70, which gives me 60 times 6 times 7, sorry, is 42. And then I add my 2 zeros on, okay, which gives me 4,200. If I add them both together, I get a total of 6,200 meters squared. Alright, so that would be your area, and that would be your perimeter. Okay, well done everyone. I think our brains are warmed up. Mine certainly is now. More so because I just have to concentrate trying to use a mouse to write on the numbers. So I do apologise. Obviously my handwriting would be much neater if it was on a normal whiteboard. Okay, so what are fractions? What I want you to do now is have a think. What do you think fractions are? So anything at all. When we say the word fraction, what do you think of? Pause the video and have a think. Right then everyone, welcome back. Let's see. So what are fractions? We'll discuss it. So again, we did something similar yesterday, talking about what fractions are. So hopefully you might have used the terminology denominators and numerators. So you've remembered about denominators and numerators. The demon at the bottom, the numerator at the top, unit and non-unit fractions, you might have mentioned that as well. But usually fractions means less than 1, like I said on yesterday's video, usually less than 1, and a slice of, or a chunk of, or a bit of something. Often an amount of a number, or often an amount of 1. So when do we use fractions? Well, fractions, it's not one of those things that you learn in maths in school and it's pointless. Fractions you use throughout life. So from cutting up your food, if you're sharing it, if you've got family, you've got friends around, pizza is a great example of that, where you have to equally cut your pizza into fractions, into eighths mainly, or quarters. You'll see fractions on road signs and just signs in general, warning you of of things, and quite often using halves and quarters and so forth. Shops all the time, so if you like shopping, you need to be good at fractions to work out your discounts. My wife, funnily enough, is rubbish at maths, but she's fantastic at fractions because she's so good at shopping. She doesn't know her times tables, but she can work out what 50% of a total is. Priorities. Sometimes if you're working in the building trade, you need to use fractions, whether you're building a wall, whether you're building anything really. Alright, you need to sometimes work out what a quarter of something is, and so forth. And then money as well. Money, we're always thinking about fractions of money, what half of a total is, or a quarter of a total is. Alright, often linking then back to shopping. So yeah, it's definitely a skill which is important, we do need to know. So let's recap, unit and non-unit fractions. So what fractions of the cubes are each colour? Let's have a look. So the first thing we do is we have to write the denominator at the bottom. Alright, so that's the total. What is it out of? So we've got 7 cubes there, so we know it's out of 7. And then your numerator is the amount of what you're looking for. In this case, we're looking for yellow cubes. Alright, so we put our denominators in, it's all out of 7. How many yellow? We've got 4 yellow cubes, so the fraction is 4/7 are yellow cubes. Reds, we've got 2, so it's 2/7, and just the 1 green, so 1/7 of the cubes are green. Alright, so question 2 says, which of the above fractions are unit fractions? So, can you answer that question? Well done if you said the unit fraction here is green. Green's the unit fraction because it's the only fraction where it's got 1 as a numerator. So if you've got 1 as a numerator, it means it's a unit fraction. Okay, which of these, question 2, are non-unit fractions? It's all of the others. Alright, so it is this one and this one because they have a numerator other than 1 or greater than 1. Alright, and there's our answers just to clarify that. So what fraction is being represented here? There are how many equal parts altogether? So we count, using the bar, we count how many, imagine this is a bar of chocolate. Okay, how many parts are all together? 1, 2, 3, 4, 5. So we've got 5 parts altogether. Okay, and then it says, this is asking for a fraction. What out of how many equal parts are shaded? And what percentage of the shape is shaded? Okay, and this as a fraction. So I'm going to pause there, have a think, and then we'll go through it together. Okay, off we go. Okay, right, let's have a look. How did you do? So what are equal parts altogether? So how many pieces are there altogether? We've got 5. Yeah, there's 5. 5 parts. 1 out of the 5 parts is shaded. So as a fraction we write it like this, 1/5. 1/5 of the shape is shaded. Therefore this is a unit fraction. So let's have a go at this one now. Okay, so what fraction are shaded red? So I want you to have a go at this. Fill in the blanks and then we'll check it together, okay? Pause the video now. Welcome back. Let's see. So there are how many equal parts altogether? So what's the total amount of, in this case, balls or circles? We've got 4. How many are red? 3 out of 4 parts are red. As a fraction, how would you write it? 3/4 or 3/4. Alright. And therefore, what type of fraction is this? This is a non-unit fraction because we have a 3 which is greater than 1. Therefore, it is a non-unit fraction. Right, and let's have a look at this. So, which of these representations show 1/4 and y? So, look at these shapes. I want you to just go through yourself and just a simple yes or no or a tick or a cross. Which of these shapes are fair representations of 1/4? Pause the video now. Okay, right, let's check together. Let's see how you did. The first one is, alright, so that is a representation of 1/4 because 1 out of the 4 circles are shaded. So that would be a tick. The next one is incorrect because that actually shows 1/5. There's 5 sections. The next one also would be incorrect because actually what that's showing is 4 shaded squares and 1 not shaded, so 4 out of the 5. So that would be 4/5. And then the final one, even though it's 4 quarters, even though it's split into 4 sections, the sections need to be of equal size. So just by looking at that, we know that's not 1/4 because there's no way that that is the same size as that, for instance. Alright, bottom one, again, it's not been split into equal sections to begin with, and also it's split into 2 sections, so definitely not. However, if you were to do it like that and split it like that, then you would say, now I can see it is split, therefore it is 1/4. Okay, so sometimes I don't always show the lines, which makes it quite tricky, but now you can see that it would be 1/4. The next shape, hopefully straight away we can get it, that's 1/4. They're split into equal slices as well. Likewise, so it's the next shape. And the final shape, 1 out of 4 is shaded, however they're not equal sizes, so it wouldn't be 1/4. Okay, it's important that they are the same size as well. What I'd like to do now is pause the video once I finish speaking, have a go at questions 1 to 4, and we will then check in and go through the next part of the worksheet. Good luck everyone, pause the video now. And welcome back. Hopefully you found that okay. And I look forward to checking your work later. Let's move on then. So we've got a number line 0, 1, 2, 3, 4 and 5, and it's showing us using visual representations of value of each. Okay, so we've got 1 hole, we've got 2 hole, 3 hole, 4 hole and 5 hole. So we could say 5 hole sweets, 5 hole pizzas. And what we've done there is we've dragged the 1 hole down to create a new number line, and we're going to create a new number line using fractions now. Alright, because like I said, most fractions, the vast majority of the time, they represent less than a whole, less than 1. So if we look now at the scale, we've got 0 here, we've got 1, 2, 3, we've got 4 lines. So what is the size, what is the value of this? Alright, can you see? It's split into 4. So what is the value of each scale? Let's use some visual representations to help us here. So we've got 4 sections here. Alright, so if we draw a circle that represents 1 and split into 4 sections, that's our 4 sections. From here to here is just one of the 4 sections. Okay, so it's 1 out of 4. So how would we say that? It's a fraction. It's 1/4 or 1/4. To get to the middle, okay, it's a second scale. So 1, 2. So this will be 2 out of 4, like so. Therefore, as a fraction, it's 2/4. And finally, this is the third section of our scale. So we counted in quarters: 1/4, 2/4. This must be 3/4. It's a third scale, like so. And we write it like that. Okay. And then finally we've got one hole at the end, so your whole pizza or your whole sweet is complete. I should probably use some healthy options, shouldn't I, instead of referring to sweets and pizza, but it's not quite the same if I refer to 1 whole avocado, is it? Okay, what fraction is the arrow pointing to here? Have a think. So firstly look at the number. We know it's going to be less than 1. Count how many sections, that will give you a denominator. Okay, and then count how many scales across, and that will give you your numerator. Have a think, good luck. Okay, let's see if you're alright, shall we? Oh, sorry, wrong way. So what fraction is the arrow pointing to? So straight away we count how many sections there are, okay, or how many scales, and there are 1, 2, 3, 4, 5. So we know that our denominator is going to be 5. So we're talking fifths. Okay. How many up to here? Well, it's 1, 2, 3. We've got 3 sections here. Imagine it's a chocolate bar. Okay, that's pointing to the first 3 sections. Okay, so therefore your numerator would be 3. where would 6/7 go on this number line? So now we've got a number line at the bottom. It's giving you, it's telling you it's in 7ths. Let's just double check. 1, 2, 3, 4, 5, 6, 7. Yeah, it's in 7 sections. Where would 6/7 go on the number line? Again, have a think. Where do you think the arrow would go? And point to it. Let's see if you're right. So 1/7, 2/7, 3/7, 4/7, 5/7, and 6/7. Alright, so 6/7 will go here because it is the 6th. It's the 6th section across. Alright, or the 6th scale across. Well done, everyone. Fabulous listening. I want you to now have a go at the rest of the worksheet. Once you've finished the worksheet, I have a challenge for you as well. Okay, so I'd like to pause the video and complete the worksheet and then come back and watch the final part of the video. Good luck, everyone. Pause the video now. Welcome back. Fabulous Maths. Hopefully you are now ready for a challenge. Here we are. So we have a challenge. We have A, B and C. So some of you I know at home might be watching this from a phone, so I will read out the challenges for you. So challenge A, you have got, hopefully you can see the representations, but we've got fractions shown in different ways. And it says, which image is the odd one out? Alright, so look, and can you work out which one is the odd one out? Complete this on paper and send it to me, that would be fabulous. And then underneath, once you've worked it out, it says, can you redraw the image to show the correct fraction? So once you've discovered the odd one out, can you recreate the image to show the correct fraction, the same fraction as the others? Okay. And then underneath here we've got Leah. She thinks that the fraction represented below is 1/5. Is she correct or not? So does this picture representation show 1/5? Yes or no? Explain your reason why. B, very similar. Which image is the odd one out? So very similar to first question on A. Again, once you've found the odd one out, can you redraw the correct? Can you redraw an image to show the correct fraction? And underneath we've got Tom thinks one of the fractions represented is 3/7. Is he correct? So look at the birds. Is 3/7 represented there? Yes or no? Again, I don't want just yes or no, I want you to explain how you know. And then moving on to C, Amy thinks one of the fractions represented below is 3/12. Is she correct? So again, you might want to count up and total the fish first to work out your denominator. And then, is there a group of 3 of specific fish? Yes, no. Again, explain and prove how you know. And question, your final question, Sam writes a fraction of a number. Let's just move my camera slightly a minute. And we have a scale or a number line to show. Alright, and he's got 6/8 in the middle. Apologies if you can't quite see the bottom. It basically says, is Sam correct? Explain your answer. No, sorry, it said, why is Sam incorrect? So we know that Sam is incorrect, but how do you know? So we've got 6/8 right in the middle. Think about where 6/8 should go. Okay, there's a clue. Or what should go in the middle as opposed to 6/8. Good luck with that, everyone. Thanks for listening, and I look forward to checking your maths later. Adios.